Far beyond our galaxy, beyond everything you can see in the night sky, there is another universe, hiding in plain sight. This is Andromeda Galaxy, a galaxy so massive it contains over 1 trillion stars. But what we see from Earth is only the surface, because deep inside Andromeda, there are structures, patterns, and secrets that we were never meant to see until now. Welcome to Stellar Depth. Don't forget to subscribe, because tonight we're going inside a galaxy. When we look up at the night sky, what we see feels complete. Stars scattered across darkness, forming patterns, creating something familiar. But what if everything you see is only a small part of something much larger? Because far beyond our own galaxy, there is another one, vast, massive, and closer than you might think. This is the Andromeda Galaxy, a structure so enormous that it contains over 1 trillion stars, more than twice the number in our own galaxy. From Earth, it appears as a faint blur of light, almost invisible to the naked eye. But that small glow is an entire galaxy, stretching across space for more than 200,000 light-years. To understand what that means, imagine light itself, the fastest thing in the universe, traveling without stopping for 200,000 years, just to cross from one side to the other. And yet, this is only its size. The real mystery lies inside it, because galaxies are not just collections of stars. They are systems, complex, layered, dynamic, filled with motion and hidden structures that cannot be seen from the outside. For a long time, Andromeda remained distant, unreachable, a silent presence in the sky. But everything changed when we began to observe it with something more powerful, the Hubble Space Telescope. Unlike ground telescopes, Hubble sees the universe without interference. No atmosphere, no distortion, only clarity. And when it turned toward Andromeda, it didn't just capture an image. It revealed something we had never seen before. A level of detail so precise that individual stars inside another galaxy became visible. Not clusters, not shapes, but stars, points of light that exist millions of light-years away. This changed everything, because for the first time, Andromeda was no longer just a distant object. It became a place, a real structure, with depth, with layers, with regions that could be explored. And what we found inside was far more complex than expected. Different zones, different star populations, regions where stars are being born, and others where they are dying, all happening at the same time, all within the same galaxy. This is where the story begins to change. Because when we observe something this large, we expect patterns, order. But inside Andromeda, there are irregularities, unusual distributions, structures that don't behave the way they should. Some areas are too dense, others too empty, as if something has reshaped the galaxy over time. This suggests that Andromeda is not stable, not fixed. It is evolving, changing, just like everything else in the universe. And the deeper we look, the more we realize that what we see now is only a moment, a snapshot in a much longer process. Because galaxies do not remain the same. They collide, they merge, they absorb smaller systems, and each interaction leaves a mark, a signature hidden inside the structure. Andromeda carries those marks, evidence of past events, written across its stars. But from this distance, We can only see the surface of those changes. We can observe patterns, but we don't fully understand what caused them. Not yet, because to truly understand what's happening, we need to go deeper, inside the galaxy, beyond the outer glow, into the regions where structure becomes complex, where gravity shapes everything, where motion becomes unpredictable, and where the real story of Andromeda begins to unfold, because what Hubble revealed was only the beginning. And in the next part, we will go further inside to explore the hidden structure of Andromeda and what lies beneath its surface. As we begin to move deeper into Andromeda, the galaxy starts to change. From the outside, it appears smooth, balanced, a spiral of light stretching across a space. But inside, that structure begins to break apart into something far more complex, because a galaxy is not uniform. It is divided into regions, each one with its own behavior, its own history, and its own role in shaping the whole. The outer edges are the first layer, a wide, faint halo of stars, spread thinly across vast distances. These stars are ancient, some of the oldest in the galaxy. They move slowly, following long, wide orbits around the center. Nothing here is crowded. Nothing is intense. Just a quiet, distant region, holding the earliest memory of the galaxy's past. But as we move inward, everything changes. The stars become denser, closer together. The light becomes stronger. This is the disk, the main body of Andromeda, a massive rotating structure filled with billions of stars. Here, motion is constant. Stars orbit the center at incredible speeds, hundreds of kilometers per second. And yet, from a distance, it all appears smooth, like a perfect rotation. But that illusion doesn't last, because inside the disk, there are patterns, spiral arms, curving structures made of stars, gas, and dust. These arms are not solid. They are waves, regions where matter is compressed, where density increases, and where something important happens: star formation. Because inside these spiral arms, new stars are born. Massive clouds of gas collapse under gravity, heating up until they ignite, becoming stars, bright, young, powerful. And these stars change everything around them. They emit energy, radiation, winds, all shaping the environment of the galaxy. This creates a contrast between regions of creation and regions of stillness. Some parts of Andromeda are alive with activity, others are almost silent. But even this is only the surface of what's happening, because beneath the visible structure, there are deeper forces. Gravity being the most important. Every star, every cloud of gas, every particle is affected by it, pulled toward the center, held in motion by a balance between speed and attraction. But here's the problem. When scientists measured that motion, something didn't match. The stars were moving too fast. Faster than the visible mass of the galaxy could explain. Which means something else is there, something invisible, something massive, something we cannot see. This is what we call dark matter, a hidden structure that surrounds the galaxy, extending far beyond what we can observe, and holding everything together. Without it, Andromeda would not exist as it does. The stars would drift apart. The structure would collapse. But dark matter creates a framework, a gravitational skeleton that shapes the galaxy from the inside out. And this changes how we see everything, because what we observe, the stars, the light, is only a small part of the full structure. Most of the galaxy is invisible, hidden, yet essential. And as we go deeper toward the center, the intensity increases. The stars become even more dense, packed together in ways that are hard to imagine. Light overlaps, motion becomes chaotic, and the environment becomes extreme. This is the inner region, a place where gravity dominates everything, and where the true core of Andromeda waits, because at the very center, there is something far more powerful than anything we've seen so far, something that controls the motion of the entire galaxy, something invisible but undeniable. And in the next part, we will move directly into that core, to uncover what lies at the center of Andromeda, and why it may be the most dangerous place in the entire galaxy. As we move closer to the center of Andromeda, everything begins to change once again. The calm rotation of the outer regions disappears. The ordered spiral arms fade away, and what replaces them is something far more intense, because the core of a galaxy is not like the rest. It is a different environment, a place where gravity is no longer balanced in the same way, where stars are not spread across space, but compressed into a much smaller region, closer, brighter, and far more chaotic. This region is known as the galactic bulge, a dense sphere of stars surrounding the center. Here, millions of stars can exist within distances that would be considered empty elsewhere. If you were standing inside this region, the sky would not be dark. It would be filled with light. Stars in every direction. Some so close, they would outshine anything we see from Earth. But this beauty hides something dangerous. Because where stars are this close, interactions become inevitable. Gravitational pulls between stars begin to distort their paths. Orbits become unstable, and over time, collisions can occur. Not frequently, but often enough to shape the region over billions of years. This creates a constantly changing environment, a place where motion is unpredictable, where stability does not exist in the way we understand it. But even this is not the most extreme part, because at the very center of Andromeda, there is something else, something far more powerful, a supermassive black hole, an object with a mass millions of times greater than our Sun, invisible but dominant. It does not shine. It does not emit light in the way stars do. And yet, it controls everything around it. The stars near the center move at incredible speeds, orbiting something they cannot see. Their motion reveals its presence, because only something with immense gravity could hold them in such tight orbits. This black hole is not just a feature. It is the core, the anchor of the entire galaxy. Without it, the structure of Andromeda would be completely different. But here's where the mystery deepens, because unlike some galaxies, Andromeda's core is not simple. It is not centered around a single point of light. Instead, it appears to have two centers, two bright regions orbiting each other. This is something we did not expect. A double nucleus. A structure that suggests a complex history. Possibly the result of a past collision, or a merger with another galaxy, meaning that Andromeda has not always been what it is now. It has changed, grown, absorbed other systems, and each event has left a mark inside its core. This makes the center of Andromeda not just powerful, but unstable, a place where the past and present interact continuously, where gravity shapes everything, and where the structure is still evolving. But there's something else, something even more important, because when we observe the motion of stars near the center, we notice patterns, unexpected ones, clusters of stars moving together, as if influenced by something beyond simple gravity. This suggests that the core may hold more complexity than we currently understand. Hidden structures, invisible forces, or remnants of events we have yet to fully explain. And this is what makes Andromeda so fascinating, because even with the most advanced technology, we are still discovering new details, new questions, new mysteries. The deeper we look, the less simple the galaxy becomes. And as we continue to explore, we begin to realize something important. We are not just observing a distant object. We are witnessing a system in motion, a structure that is still evolving, still changing, still revealing its secrets, one layer at a time. And in the next part, we will go even further, beyond the visible structure, to explore the hidden interactions that may have shaped Andromeda, and what they tell us about its future. As we move beyond the visible core of Andromeda, a new layer of the galaxy begins to emerge, not one defined by light, but by interaction, because galaxies are not isolated. They exist in a universe filled with other structures, other systems, other galaxies, and over time they interact, sometimes subtly, sometimes violently, and Andromeda is no exception. In fact, its current form is the result of countless past interactions, collisions, mergers, encounters with smaller galaxies, each one leaving behind traces, signatures hidden inside its structure. These are not always obvious. You won't see them as bright features, but they exist in the motion of stars, in the distribution of matter, in the way the galaxy is shaped. One of the most important clues comes from stellar streams, long, faint trails of stars stretching across space. These are the remains of smaller galaxies that were pulled apart, absorbed by Andromeda. Over time, their structure was destroyed, but their stars remained, scattered along paths that reveal what once existed. This tells us something critical. Andromeda is not just a galaxy. It is a collection of histories, a structure built from other structures, layer by layer, over billions of years. But this process is not finished. It is still happening, even now. There are smaller galaxies orbiting Andromeda, bound to it by gravity. Some of them will remain stable for long periods. Others will not. Because over time, gravity pulls them closer, slowly, until they reach a point where their structure can no longer hold together. And when that happens, they begin to break apart. Their stars are stretched, pulled into streams, and eventually absorbed, becoming part of Andromeda itself. This is how galaxies grow, not just through formation, but through consumption, through interaction, through change. But there is something else, something even more significant. Because Andromeda is not only interacting with smaller galaxies, it is moving toward something much larger, our own galaxy, the Milky Way. Right now, both galaxies are on a collision course, moving toward each other at incredible speed, hundreds of kilometers per second. And although it may seem distant, this event is inevitable. In about 4 billion years, Andromeda and the Milky Way will begin to merge. At first, nothing will seem to happen. The galaxies will pass through each other. Stars will rarely collide because of the vast distances between them, but gravity will begin to reshape everything. Orbits will change. Structures will distort. The spiral forms will break apart. And over time, both galaxies will become one, a single, larger system. This future event changes how we see Andromeda, because it is not static, it is not permanent, it is moving toward transformation, just like everything else in the universe, and the signs of that transformation are already visible in its structure, in its motion, in the remnants of past interactions. Everything we observe is part of a process that has been unfolding for billions of years and will continue long after we are gone. This is what makes Andromeda so powerful as a subject, because it is not just a distant galaxy. It is a future, a glimpse of what is coming. And in the next part, we will explore what that collision will actually look like, and how it will transform both galaxies into something completely new. As we begin to imagine what will happen when Andromeda and the Milky Way finally meet, the scale of the event becomes almost impossible to comprehend, because this is not a simple collision like those we experience on Earth, but an interaction between two massive galaxies, each containing hundreds of billions of stars, vast clouds of gas, and an unseen structure of dark matter holding everything together. The approach itself will take millions of years, a slow and steady movement driven by gravity, where both galaxies begin to distort long before they actually touch. Their outer regions stretching, their shapes warping, and their structures becoming less defined as they fall deeper into each other's gravitational influence. From a distance, the first visible sign would be the elongation of both galaxies, as tidal forces begin to pull stars away from their original orbits, creating long streams of light that extend into space, forming bridges between the two systems. These stellar streams are not random. They follow the invisible lines of gravitational interaction, tracing the paths along which matter is being redistributed, showing us exactly how the galaxies are beginning to merge. As the interaction continues, the two galaxies will pass through each other, not as solid objects, but as vast, diffuse systems, where the probability of individual stars colliding remains extremely low. Yet the overall structure is dramatically affected. Stars that once followed stable orbits will be pushed into new trajectories, some thrown outward into the halo, others pulled inward toward the center, creating a chaotic environment where motion is no longer predictable. At the same time, the gas clouds within both galaxies will collide directly, compressing and heating up, triggering intense bursts of star formation, far more powerful than anything currently observed in either galaxy. Entire regions will light up with new stars, massive, bright, and short-lived, dramatically changing the appearance of the merging system. Over time, the repeated passes of the two galaxies will cause them to lose their original spiral structure. The well-defined arms of Andromeda and the Milky Way gradually dissolving into a more irregular and disturbed shape. Eventually, after multiple interactions, the two systems will settle into a new equilibrium, forming a single, larger galaxy, likely elliptical in shape, with a much more uniform distribution of stars. At the very center of this new galaxy, something even more extreme will occur, because both Andromeda and the Milky Way contain supermassive black holes, and as the galaxies merge, these two massive objects will move closer and closer together, eventually forming a binary system where they orbit each other, emitting gravitational waves as they lose energy. Over time, they will spiral inward and finally merge, creating an even more massive black hole at the center of the newly formed galaxy, releasing an enormous amount of energy in the process, a signal that could be detected across vast distances in the universe. This final stage represents the complete transformation of both galaxies from two distinct systems into one unified structure, shaped by gravity, motion, and time. And while this entire process will take billions of years, far beyond human timescales, it is already in motion, already determined by the paths these galaxies are following. What makes this realization so powerful is that it shows us that even the largest structures in the universe are not permanent, that they evolve, interact, and transform over time, just like smaller systems. Andromeda, which once appeared as a distant and separate galaxy, is in fact part of our future, a system that will eventually merge with our own, reshaping everything in a way that we can only begin to imagine. In this sense, the story of Andromeda is not just about understanding a distant galaxy, but about understanding the dynamic and ever-changing nature of the universe itself, where nothing remains fixed, and where even the grandest structures are part of a continuous process of evolution and transformation that spans billions of years. As the collision between Andromeda and the Milky Way continues to unfold over millions of years, the transformation becomes more intense, more chaotic, and far more dramatic than anything we can easily imagine. Because this is not a single moment, but a long sequence of interactions where gravity reshapes everything step by step. After the first pass, both galaxies begin to lose their original identity, their spiral arms stretched and distorted into long streams of stars that extend far beyond their original boundaries, forming massive tidal tails that arc through space like glowing ribbons. These structures are not temporary. They carry stars that may never return to the main body of the galaxy, permanently changing the distribution of matter. As the galaxies swing past each other, gravity pulls them back again, beginning a second approach, a slower and deeper interaction where the cores move closer and the surrounding regions become even more mixed. During this stage, the internal motion of stars becomes increasingly unpredictable, with some stars being pushed into new orbits far from the center, while others are drawn inward, creating dense regions where gravitational interactions become stronger and more frequent. At the same time, the collision of gas clouds continues to trigger waves of star formation, producing clusters of young, massive stars that shine intensely, but live only for short periods, eventually exploding as supernova and injecting energy back into the system. This cycle of formation and destruction adds another layer of complexity to the merging galaxies, making the environment highly dynamic and constantly changing. As the process continues, the distinction between Andromeda and the Milky Way fades, their structures blending together into a single, irregular system where it becomes impossible to separate one from the other. Over time, the repeated interactions dissipate energy, allowing the system to settle into a more stable configuration. But this stability is very different from what existed before, because the original spiral structure is gone, replaced by a more rounded elliptical shape, where stars move in a wider range of orbits, creating a smoother and more uniform distribution of light. At the center of this new galaxy, the two supermassive black holes continue their approach, forming a binary system that dominates the inner region, their immense gravitational pull affecting the motion of nearby stars and gas. As they orbit each other, they lose energy through the emission of gravitational waves, slowly spiraling closer until they eventually merge in a single, powerful event that releases an enormous amount of energy, reshaping the core of the galaxy and creating a new, even more massive black hole. This final merger marks the completion of the transformation, the point where two separate galaxies have fully combined into one, carrying with it the history of both systems and the evidence of their interaction. What makes this entire process so remarkable is that it shows us how galaxies evolve over time, not as static objects, but as dynamic systems that grow, change, and interact with each other in ways that can completely alter their structure. Andromeda, which we once saw as a distant and separate galaxy, becomes part of our own cosmic story, a system that will eventually merge with ours and create something entirely new. This realization changes how we think about the universe, because it shows that even the largest structures are not permanent, that they are part of an ongoing process of formation and transformation that continues over billions of years. And as we look at Andromeda today, we are not just seeing what it is, but what it will become, a future event already set in motion, slowly unfolding across time on a scale far beyond human experience. As the merged system begins to settle after the long interaction between Andromeda and the Milky Way, something entirely new starts to emerge. Not a simple combination of two galaxies, but a transformation into a structure that is fundamentally different from both. The familiar spiral arms that once defined each galaxy are gone, replaced by a more rounded and diffuse shape, where stars no longer follow organized patterns but move in a wide range of orbits, creating a smooth elliptical form that reflects the loss of the original structure. This new galaxy, often referred to by scientists as a future Milkomeda, represents the next stage in the evolution of large galactic systems, a stage where repeated interactions have redistributed energy and motion to the point where stability is achieved in a completely different way. Instead of the clear rotation seen in spiral galaxies, the stars in this new system move in more randomized paths, forming a dense central region surrounded by a gradually fading halo, with fewer distinct features and a more uniform appearance. But even in this state, the galaxy is not static, because the processes that shape it continue to operate, albeit more slowly. Star formation may decrease over time as the available gas is used up or heated to the point where it can no longer collapse into new stars, leading the galaxy toward a quieter phase, where fewer bright young stars are created, and the overall light becomes dominated by older, cooler stars. At the same time, the central supermassive black hole, now larger after the merger of the original two, continues to influence the inner region, shaping the motion of nearby stars, and occasionally interacting with surrounding material in ways that can produce bursts of energy. This central region becomes the most active part of the galaxy, while the outer regions remain relatively calm, holding the remnants of the original structures in the form of faint streams and irregular distributions of stars that trace the history of the merger. Over billions of years, even these features begin to fade, as gravitational interactions smooth out the remaining irregularities, gradually erasing the visible signs of the collision and leaving behind a more uniform system. This process highlights an important aspect of the universe, that even the most dramatic events eventually settle into new forms of equilibrium, where the effects of past interactions are still present but become less obvious over time. And yet, the history is never completely lost. It remains encoded in the motion of stars, in the distribution of matter, and in the overall structure of the galaxy, waiting to be uncovered by careful observation and analysis. When we consider this final stage, it becomes clear that the story of Andromeda is not just about a single galaxy, but about the life cycle of galaxies in general, from formation to interaction, to transformation and eventual stabilization. It shows us that galaxies are not permanent structures, but evolving systems that change over time, influenced by both internal processes and external interactions. And as we look at Andromeda today, we are witnessing just one moment in that cycle, a moment before a major transformation that will reshape both it and our own galaxy into something entirely new. This perspective allows us to see the universe not as a collection of fixed objects, but as a dynamic system where change is constant and where even the largest structures are part of an ongoing process that spans billions of years, a process that continues far beyond anything we can directly observe, yet one that defines the very nature of the cosmos. As we step even further into the future of this merged galaxy, the story begins to slow, not in importance, but in motion, because after the chaos of collision, after the violent reshaping of structure, what remains is a system that has entered a new phase, one defined not by dramatic change, but by gradual evolution over immense timescales. The galaxy that formed from Andromeda and the Milky Way is now larger, more massive, and more stable in its overall structure. But this stability does not mean inactivity. It means that change happens more slowly, more subtly, and in ways that are harder to observe. The bright bursts of star formation that once lit up the merging galaxies begin to fade as the available gas is consumed or dispersed, leaving behind a population of stars that is older, cooler, and less dynamic. Over billions of years, these stars continue their motion, orbiting within the gravitational field of the galaxy, their paths gradually becoming more randomized as interactions smooth out any remaining patterns. The once distinct features of the original galaxies, the spiral arms, the tidal streams, the irregular distributions of matter, all begin to blend into a more uniform structure, a process that slowly erases the visible traces of the past while preserving its effects in the underlying dynamics of the system. At the center, the merged supermassive black hole continues to dominate, its influence extending far into the surrounding region, shaping the motion of stars and occasionally interacting with any remaining gas. Though such events become increasingly rare as the galaxy ages, this central region remains the most active part of the galaxy. But even here, the intensity decreases over time as the system approaches a state of long-term equilibrium. Beyond the central region, the outer halo of the galaxy expands, containing stars that were once part of the original systems, but have been redistributed through gravitational interactions, creating a vast and diffuse region that extends far beyond the main body of the galaxy. This halo becomes a kind of archive, holding the remnants of past events, the stars that were displaced during the merger, and the subtle signatures of the processes that shaped the system. As time continues to pass, the overall brightness of the galaxy decreases, not because it is losing stars, but because the most luminous and short-lived stars have already completed their life cycles, leaving behind a population dominated by longer-lived, less energetic stars. This gradual dimming marks the transition into a quieter phase of galactic evolution, where the dramatic events of the past give way to a more stable and enduring state. And yet, even in this state, the galaxy is not isolated. It remains part of the larger structure of the universe, influenced by the gravitational field of nearby galaxies and the overall distribution of matter in its region of space. Over even longer timescales, interactions with other galaxies may occur, continuing the cycle of growth and transformation that defines the evolution of cosmic structures. This perspective reveals that the story of Andromeda does not end with its merger with the Milky Way, but continues as part of a much larger process, one that extends across the universe and spans billions of years. It shows us that galaxies are not static objects, but dynamic systems that evolve over time, shaped by both internal processes and external interactions, and that even after the most dramatic events, they continue to change, to adapt, and to exist within the ever-evolving structure of the cosmos. In the end, what began as a distant galaxy in the night sky becomes part of a much larger narrative, a story of transformation, of continuity, and of the endless processes that shape the universe, reminding us that everything we see is only a moment in a much longer and far more complex evolution that continues far beyond our ability to observe it directly. As the galaxy formed from Andromeda and the Milky Way continues to evolve over even longer timescales, it begins to enter a phase where the changes become almost imperceptible, not because nothing is happening, but because everything is happening so slowly that it stretches far beyond any familiar sense of time. The bright, active periods of star formation have largely come to an end, leaving behind a population of stars that continues to age, cool, and move through the galaxy in stable but increasingly randomized orbits. Without large amounts of gas to fuel new star formation, the galaxy gradually becomes quieter, its light dominated by older stars that emit less energy, creating a softer, more uniform glow that slowly fades over billions of years. The central supermassive black hole remains, still influencing the inner regions, but even its activity decreases as the available material around it becomes scarce, reducing the frequency of energetic events that once shaped the core. In the outer regions, the halo continues to expand and diffuse, with stars spread across vast distances, forming a faint and extended structure that holds the memory of past interactions, but reveals little about them at first glance. Over time, even these faint traces begin to smooth out, as gravitational interactions between stars gradually erase the irregularities, leading the galaxy toward a more uniform and stable configuration. This process, known as dynamical relaxation, represents the natural tendency of systems to move toward equilibrium, where energy is distributed more evenly and large-scale structures become less pronounced. And yet, even in this state of apparent calm, the galaxy is still part of a much larger and more dynamic universe because it continues to move through space, influenced by the gravitational pull of other galaxies and the large-scale structure of the cosmos. While major interactions may become less frequent, they are not impossible, and over extremely long timescales, new encounters could once again disrupt the system, restarting the cycle of interaction and transformation. This highlights an important aspect of cosmic evolution, that there is no final state in the absolute sense, only phases that appear stable over certain periods before new processes begin. The galaxy that once was Andromeda is now part of a much larger system, one that has gone through dramatic change and now exists in a quieter phase. But its story is not over. It continues as part of the ongoing evolution of the universe. When we step back and consider this entire process, from the initial approach of two galaxies to their collision, merger, and eventual stabilization, we begin to see the universe in a completely different way, not as a collection of fixed objects, but as a dynamic and ever-changing system where structures form, interact, and transform over time. Andromeda, which once appeared as a distant and separate galaxy, becomes a key part of that understanding, a system that allows us to observe and predict the processes that shape galaxies on the largest scales. In the end, the story of Andromeda is not just about one galaxy, but about the nature of cosmic evolution itself, a continuous process that unfolds over billions of years, connecting the past, present, and future in ways that extend far beyond what we can directly experience, reminding us that everything we see is only a moment in a much larger and more complex universe that continues to evolve long after we are gone. And as we reach the end of this journey into Andromeda, everything begins to come together, not as separate ideas, but as a single continuous story about how the universe evolves over time, because what we have seen is not just a galaxy, but a process, a system in motion that exists far beyond any single moment. Andromeda, which once appeared as a distant blur of light in the night sky, becomes something far more meaningful when we understand what it truly is, a vast and dynamic structure made of stars, gas, dark matter, and hidden forces, all interacting over billions of years to create the shape we observe today. It is not fixed, it is not permanent, and it is not separate from us. It is part of the same cosmic system that includes our own galaxy, moving toward a future where both will merge and transform into something entirely new. This realization changes how we see the universe, because it shows us that even the largest structures are not static, but constantly evolving, shaped by gravity, motion, and time. The collision between Andromeda and the Milky Way is not a distant possibility. It is an inevitable event, already set in motion, slowly unfolding across billions of years, and what we see today is only the beginning of that process. As the galaxies move closer, interact, and eventually merge, they will create a new system, one that carries the history of both and continues the cycle of cosmic evolution. This cycle does not end with the formation of a new galaxy. It continues as that galaxy interacts with others, changes over time, and becomes part of an even larger structure, showing us that the universe is not defined by isolated objects, but by the relationships and interactions between them. Andromeda is a perfect example of this, because it reveals how galaxies grow, how they change, and how they connect to one another across vast distances and timescales. When we look at it now, we are not just seeing a galaxy as it is, but as it was in the past and as it will be in the future, because the light we observed today left Andromeda millions of years ago, meaning that we are always looking back in time when we observe distant objects. This adds another layer to the story, showing us that our view of the universe is not a snapshot of the present, but a collection of moments from different times, all combined into a single image. And in that image, Andromeda stands as both a distant object and a future event, a system that we can study to understand not only what exists beyond our galaxy, but what will eventually happen to it. In the end, the story of Andromeda is not just about distance or scale, but about connection, about how everything in the universe is linked through gravity, motion, and time, forming a continuous and ever-changing structure that extends far beyond what we can fully comprehend. And as we step back from this journey, the final image remains clear: a vast galaxy moving through space, filled with billions of stars, shaped by forces we are only beginning to understand and slowly, inevitably, becoming part of something even greater. A reminder that the universe is not still, not silent, but alive with motion, transformation, and an endless story that continues to unfold across the depths of space. Even after everything we've uncovered about Andromeda, there is still a deeper layer to its story, one that goes beyond structure, beyond motion, and into the very nature of how we observe the universe, because what we see when we look at this galaxy is not its present, but its past. The light that reaches us from Andromeda has traveled for more than 2 million years, meaning that every detail we observe today is a record of what the galaxy was like long before human civilization even existed. This changes everything, because it means that our understanding of Andromeda is built entirely on delayed information, a view that is always slightly behind reality. While we observe a spiral galaxy with defined arms and visible structure, the actual Andromeda that exists right now may already be different, already evolving, already moving closer to the Milky Way in ways that we cannot directly see yet. This concept extends across the entire universe, where distance and time are deeply connected, creating a situation where observing space is essentially observing history. Every star, every galaxy, every structure we see is part of a timeline that stretches back across millions or even billions of years, allowing us to study the evolution of cosmic systems by looking at different objects at different distances. In this sense, Andromeda is not just a single galaxy, but a reference point in time, a way for us to understand how galaxies form, change, and interact over long periods. When we combine this with what we know about its future, the inevitable collision with the Milky Way, we begin to see Andromeda as something that exists across multiple points in time simultaneously. A past that we can observe, a present that we can only infer, and a future that we can predict based on the laws of physics. This multi-layered perspective reveals something profound about the universe, that it is not experienced all at once, but in fragments, each one representing a different moment in the ongoing process of cosmic evolution. Andromeda becomes a bridge between these moments, connecting what has already happened with what is yet to come, allowing us to piece together a larger picture of how galaxies behave over billions of years. This also highlights the limitations of our observation, because no matter how advanced our technology becomes, we are always bound by the speed of light, always looking back in time, always reconstructing reality from signals that have taken vast amounts of time to reach us. And yet, within those limitations, we are able to understand processes that occur on scales far beyond human experience, predicting events that will happen long after we are gone, and uncovering the history of systems that formed long before we existed. Andromeda is a perfect example of this, a galaxy that appears as a distant object in the sky, but that represents a complex and evolving system with a past, present, and future that are all connected through the flow of time. In the end, what makes Andromeda so fascinating is not just its size or its proximity, but its role as a window into the nature of the universe itself, a reminder that what we see is never the full story, that reality extends beyond our immediate perception, and that every observation we make is part of a much larger narrative that continues to unfold across space and time. As we continue to look deeper into Andromeda, we begin to realize that what we are truly observing is not just a galaxy, but a system of layers, each one holding a different part of its history, each one revealing something about how it was formed and how it continues to evolve. The outer halo, with its faint and ancient stars, tells us about the earliest stages of the galaxy's existence, when matter first began to gather and structure started to form. The disk, with its rotating stars and spiral arms, shows us a more active phase, where motion and interaction create patterns that can be observed and studied. And at the center, the dense core and the supermassive black hole reveal the most extreme conditions, where gravity dominates everything, and where the structure of the galaxy is held together in its most concentrated form. These layers are not separate, they are connected, each one influencing the others, creating a system where change in one region can affect the entire galaxy over time. This interconnected structure is what allows Andromeda to evolve, to respond to interactions, and to adapt to the forces acting on it. But beyond the visible layers, there is something even more important, something that cannot be seen directly, but that shapes everything we observe, and that is dark matter. This invisible component forms a vast halo around the galaxy, extending far beyond the visible stars and providing the gravitational framework that holds the entire system together. Without it, the motion of stars would not match what we observe, and the galaxy would not be stable over long periods of time. This means that most of Andromeda's mass is not visible, and that what we see is only a small part of its true structure. This realization changes how we think about galaxies, because it shows that they are not defined only by the light they emit, but by the invisible forces that shape their motion and evolution. When we combine all of this, the visible layers, the internal dynamics, and the hidden structure of dark matter, we begin to see Andromeda as a complete system, one that exists not just as a collection of stars, but as a complex and evolving structure shaped by both visible and invisible components. And this understanding allows us to place Andromeda within the larger context of the universe, as part of a network of galaxies that interact, merge, and evolve over time, contributing to the overall structure of the cosmos. In the end, what Andromeda reveals to us is not just the nature of one galaxy, but the principles that govern all galaxies, showing us how they form, how they change, and how they are connected through the fundamental forces of the universe. As we move beyond structure and observation, Andromeda begins to reveal something even deeper, something that goes beyond stars, beyond motion, and beyond what we can directly measure. Because what this galaxy ultimately shows us is how the universe builds complexity over time. Every part of Andromeda, from its faint outer halo to its dense central core, is the result of countless processes acting together. Gravity pulling matter inward, motion spreading it outward, and interactions reshaping everything again and again across billions of years. This continuous cycle creates a system that is not fixed, but constantly evolving, where nothing remains exactly the same, and yet the overall structure persists. What makes this so remarkable is that all of this happens without any central control, without any guiding force beyond the fundamental laws of physics, and yet the result is something incredibly organized, a galaxy with patterns, layers, and behaviors that we can observe and begin to understand. Andromeda is a perfect example of how simple rules, applied over vast scales of time and space, can create structures of incredible complexity, showing us that the universe is not random in the chaotic sense, but structured in a way that emerges naturally from the interaction of its basic components. When we look at the spiral arms, we see patterns formed by density waves moving through the disk, organizing stars and gas into visible structures. When we observe the motion of stars, we see the influence of gravity shaping their paths in ways that maintain the stability of the system. And when we consider the role of dark matter, we see that even the invisible parts of the universe play a crucial role in maintaining this balance. This layered complexity is what allows galaxies like Andromeda to exist over billions of years, adapting to changes, absorbing smaller systems, and evolving into new forms without losing their overall identity. But this identity is not permanent. It is temporary, a phase in a much longer process where galaxies continue to interact, merge, and transform into entirely different structures. Andromeda, which we see today as a spiral galaxy, will not remain that way forever, its future already shaped by its motion toward the Milky Way and the inevitable merger that will follow. This future transformation is not separate from its current state. It is a continuation of the same processes that formed it in the first place, showing us that galaxies are part of a continuous cycle of creation and change. And when we consider this, we begin to understand that Andromeda is not just a single object, but a moment in a much larger story, a story that includes its formation, its evolution, its interactions, and its eventual transformation into something new. This perspective changes how we see the universe, because it shows us that everything we observe is part of a process that extends far beyond our current moment, a process that connects the past, present, and future into a single, continuous flow. In the end, Andromeda is not just a distant galaxy. It is a representation of how the universe works, a system that reveals the principles of structure, motion, and evolution on the largest scales, and a reminder that everything we see is part of an ongoing story that continues to unfold across billions of years. As we reach this stage, Andromeda no longer feels like a distant object in the sky, but something far more real, a system that exists with depth, with history, and with a future that is already unfolding, even if we cannot yet see it directly. What makes this galaxy so powerful as a subject is not just its size or its proximity, but the fact that it allows us to understand something fundamental about the universe, that everything is in motion, everything is evolving, and nothing remains exactly as it is. Andromeda is not fixed in place. It is moving through space, interacting with its surroundings, shaped by gravity, and influenced by forces that extend far beyond its visible structure. Over billions of years, it has grown by absorbing smaller galaxies, reshaping its form, and building the complex structure we observe today, and this process continues, even now, as it moves closer to the Milky Way. This motion is not random. It is part of a larger pattern, a reflection of the gravitational structure of the local group of galaxies, where each system influences the others, creating a dynamic network of interactions that evolves over time. When we look at Andromeda, we are seeing the result of these interactions, a galaxy that has been shaped by its environment and that continues to respond to it. This idea extends beyond Andromeda itself, because it shows us that no galaxy exists in isolation, that every structure is connected to others through gravity, motion, and the distribution of matter across space. Even the most distant galaxies are part of this network, moving, interacting, and evolving over timescales that stretch far beyond our experience. Andromeda is simply one example, but it is one that we can observe in detail, allowing us to study these processes and understand how they work. What makes this even more significant is the realization that the future of Andromeda is already determined by its current motion, that its path toward the Milky Way is not a possibility, but an inevitability, a process that will unfold over billions of years, and that will completely transform both galaxies. This future collision is not an isolated event. It is part of the same cycle that has shaped Andromeda in the past, showing us that galaxies are constantly changing, constantly interacting, and constantly evolving into new forms. And when we consider this, we begin to see that the universe is not static, not silent, but active and dynamic, filled with processes that operate on scales far beyond anything we can directly experience. In the end, Andromeda is more than a galaxy. It is a window into these processes, a way for us to understand how the universe works, how structures form and change, and how everything is connected through the fundamental forces that govern motion and interaction. As we reach this point, Andromeda is no longer just a distant galaxy or a scientific subject. it becomes something much deeper, a reference point for understanding how the universe evolves on its largest scales. What makes this galaxy so powerful is not only what it is today, but what it represents across time, a system that carries within it the record of its past, the reality of its present, and the inevitability of its future. Every star within Andromeda is part of that story, moving through space according to the same laws that govern everything else, yet together, forming a structure so vast that it defines an entire region of the universe. This structure did not appear instantly. It formed gradually, through the accumulation of matter, through gravitational collapse, and through countless interactions with other systems, each one contributing to the shape and behavior we observe today. And this process has not stopped. It continues, even now, as Andromeda moves through space, influenced by the gravity of nearby galaxies, particularly the Milky Way, drawing closer over time in a path that will eventually lead to one of the most significant events in our cosmic future. This movement reminds us that galaxies are not isolated objects, but part of a larger system where everything is connected through gravity and motion, where the position and behavior of one object can influence another across vast distances. Andromeda is part of that system, not just as a passive member, but as an active participant, shaping and being shaped by the forces around it. When we consider its scale, the billions of stars, the immense distances, the hidden mass of dark matter, it becomes clear that what we are observing is not just a collection of objects, but a complex system that operates according to principles that apply across the entire universe. These principles, gravity, motion, energy, and time, are what allows structures like Andromeda to exist, to evolve, and to interact with others, creating the dynamic environment that defines the cosmos. And yet, despite its immense size and complexity, Andromeda is still subject to change, still part of a process that will eventually transform it into something entirely different. The future merger with the Milky Way is not just an event. It is the continuation of a cycle that has shaped galaxies for billions of years, a cycle of interaction, transformation, and renewal that defines the evolution of the universe. In this sense, Andromeda is not just a distant object we observe, but a system that is directly connected to our own, a future that we can study and understand, even if we will never experience it directly. This connection gives Andromeda a unique significance, because it allows us to see both the scale and the continuity of the universe, to understand how structures form and change over time, and to recognize that everything we observe is part of a larger, ongoing process. In the end, Andromeda is not just a galaxy. It is a demonstration of how the universe works, a system that reveals the interplay of forces that shape everything from the smallest particles to the largest cosmic structures, and a reminder that even the most distant objects are part of the same story, a story that continues to unfold across space and time, connecting everything in ways that we are only beginning to fully understand. As we move beyond everything we've explored, Andromeda begins to feel less like an object we observe, and more like a system we are part of. Because the deeper we go, the clearer it becomes that this galaxy is not separate from us, but connected to our own through the same forces that shape the entire universe. What we see when we look at Andromeda is not just a distant structure, but a moment in an ongoing process, a phase in the life of a galaxy that has already gone through countless transformations and is still moving toward another one. Its stars, its motion, its structure, all of it exists within a framework defined by gravity and time. The same framework that governs the Milky Way, meaning that the story of Andromeda is also, in a very real sense, the story of our own galaxy's future. This connection changes how we understand distance, because even though Andromeda is millions of light years away, it is still part of the same cosmic environment, influenced by the same large-scale structures, and moving within the same gravitational network. Over billions of years, this shared environment brings galaxies together, not by chance, but as a natural result of the way matter is distributed across space. Andromeda's approach toward the Milky Way is one example of this, a process that has been unfolding long before we existed, and that will continue long after we are gone. When we think about this, it becomes clear that galaxies are not isolated systems, but nodes in a much larger structure, connected through gravity and motion, interacting over immense distances and timescales. Andromeda is one of those nodes, a massive system that influences and is influenced by the space around it, contributing to the overall dynamics of the local group of galaxies. This perspective allows us to see the universe as a network rather than a collection of separate objects, where everything is linked in some way, even if those connections are not immediately visible. And within this network, Andromeda plays a significant role, not just as a nearby galaxy, but as a system that helps us understand how galaxies evolve, how they interact, and how they eventually transform into new structures. The future merger with the Milky Way is a direct result of these connections, a large-scale interaction that will reshape both galaxies and create something entirely new, demonstrating that even the most massive structures are subject to change. And yet, this change is not random. It follows the same physical laws that govern everything else, showing us that the universe operates in a consistent and predictable way, even when the processes involved are incredibly complex. In the end, Andromeda is not just a distant galaxy. It is a key part of the larger system we belong to, a reminder that we are not separate from the universe, but embedded within it, part of the same processes that shape stars, galaxies, and everything in between, and that what we observe in the distance is not just something far away, but something that is directly connected to our own place in the cosmos. As we reach this stage, Andromeda begins to shift from something we observe into something we begin to understand on a deeper level, not just as a galaxy, but as a system that reflects the fundamental behavior of the universe itself. Every part of it, from the outer halo to the dense core, exists because of balance, a balance between gravity pulling inward and motion pushing outward, a balance that allows structure to form and persist over billions of years. This balance is not permanent. It is constantly being tested, reshaped by interactions, altered by the movement of matter, and influenced by forces both visible and invisible. Andromeda exists because that balance has been maintained, but it also carries the marks of moments when that balance was disrupted, when smaller galaxies were absorbed, when structures were reshaped, and when its form evolved into what we see today. These changes are not random. They follow patterns that can be studied, revealing how galaxies grow and how they respond to the forces acting on them. When we observe the motion of stars within Andromeda, we see the result of these forces. Stars moving in paths that reflect the distribution of mass, including the unseen influence of dark matter, which provides the gravitational framework that holds everything together. This hidden structure is essential, because without it, the visible parts of the galaxy would not behave as they do, and the entire system would not be stable. This shows us that what we see is only part of the full picture, that the true structure of the universe includes components that cannot be directly observed, but that are necessary for everything else to exist. Andromeda is one of the clearest examples of this, a galaxy where the visible and invisible work together to create a stable yet evolving system. At the same time, it reminds us that stability is always temporary, that even a system as massive as Andromeda is moving toward change, toward interaction with the Milky Way, and toward a future where its current form will no longer exist. This future is not separate from its present. It is a continuation of the same processes that have shaped it in the past, showing us that galaxies are part of a continuous cycle of formation, evolution, and transformation. When we step back and look at Andromeda in this way, it becomes more than just a distant object. It becomes a representation of how the universe operates, a system that reveals the interplay between forces, the importance of balance, and the inevitability of change. It shows us that everything we observe is part of a larger process, one that connects the smallest scales to the largest, and that extends across time in ways that are difficult to fully comprehend. In the end, Andromeda is not just a galaxy we study, but a key to understanding the universe itself, a system that allows us to see how structure emerges, how it is maintained, and how it eventually transforms, reminding us that nothing in the cosmos remains fixed, and that everything is part of an ongoing story that continues to unfold across billions of years. As we continue to look deeper into Andromeda, we begin to realize that what makes this galaxy truly remarkable is not just its size or structure, but the way it reflects the fundamental processes that shape the entire universe, because everything we see within it is the result of forces that operate everywhere, on every scale. The motion of its stars, the formation of its spiral arms, the presence of its central black hole, and the invisible influence of dark matter all work together to create a system that is both stable and constantly evolving. This balance between stability and change is what allows Andromeda to exist over billions of years, maintaining its structure while also adapting to new conditions and interactions. At the same time, it reveals that nothing in the universe is truly permanent, that even the most massive and seemingly stable systems are subject to transformation over time. The future merger with the Milky Way is one of the clearest examples of this, a process that will completely reshape both galaxies, turning them into something entirely new and demonstrating that evolution in the universe does not stop at any scale. What makes this even more fascinating is that we are able to understand and predict these events, not because we have observed them directly, but because we have uncovered the underlying principles that govern how galaxies behave. These principles, gravity, motion, and the distribution of matter, apply everywhere, allowing us to take what we observe in Andromeda and use it to understand other galaxies across the universe. This means that Andromeda is not just important on its own, but as part of a much larger context, a system that helps us interpret the behavior of the cosmos as a whole. When we consider this, we begin to see that every galaxy is part of a network, connected through the same physical laws, interacting over vast distances and timescales, and contributing to the overall structure of the universe. Andromeda is one of the closest and most detailed examples we have, making it a key reference point for studying these processes. It allows us to see how galaxies form, how they change, and how they interact with each other, providing insights that extend far beyond a single system. And yet, despite everything we have learned, there is still much we do not understand, because the complexity of these systems is immense, and many of the processes involved operate on scales that are difficult to observe directly. This means that Andromeda remains a source of mystery as well as knowledge, a system that continues to reveal new details as our technology improves and our understanding deepens. In the end, what Andromeda shows us is not just how one galaxy works, but how the universe itself operates as a dynamic, interconnected system where everything is influenced by the same fundamental forces, where change is constant, and where even the largest structures are part of an ongoing process of evolution that continues across billions of years. As we move closer to the end of this journey, Andromeda begins to feel less like something distant and more like a reflection of the universe itself, because what it shows us is not just how galaxies exist, but how everything in the cosmos is connected through time, motion, and the laws that govern it. Every star within Andromeda, every cloud of gas, every unseen component of dark matter, all of it is part of a system that has been evolving for billions of years, shaped by interactions, influenced by gravity, and constantly moving toward new states of balance. This continuous process reveals something fundamental, that the universe is not static, not fixed, but always changing, always adapting, and always creating new structures from the ones that came before. Andromeda is a perfect example of this, because it carries within it the evidence of past events, the signs of absorbed galaxies, the motion of stars that reflect hidden forces, and the future path that will lead it into a collision with the Milky Way. This means that when we observe Andromeda, we are not just looking at what it is, but at what it has been and what it will become, a system that exists across multiple points in time, connected through a continuous flow of change. This perspective changes how we see the universe, because it shows us that everything we observe is part of a larger story, one that extends far beyond our own moment and continues long after we are gone. It also reminds us that even the most distant objects are not separate from us, but part of the same cosmic structure, influenced by the same forces and following the same rules. Andromeda, despite being millions of light years away, is part of our future, part of a process that will eventually reshape our own galaxy, demonstrating that distance in the universe does not mean disconnection, but simply a difference in scale. When we consider this, we begin to understand that the universe is a system of relationships, where everything influences everything else over time, creating a network of interactions that define the structure and evolution of the cosmos. Andromeda is one node in that network, a massive and complex system that helps us understand how galaxies behave, how they change, and how they connect to one another across vast distances. In the end, what Andromeda reveals is not just the nature of a single galaxy, but the nature of the universe itself, a place where everything is in motion, where change is constant, and where even the largest structures are part of an ongoing process that never truly ends, but continues to evolve, to transform, and to shape the cosmos in ways that we are only beginning to understand. And now, as we reach the end of this journey into Andromeda, everything begins to settle into a single powerful realization that what we have been observing is not just a distant galaxy, but a reflection of how the universe itself exists and evolves across time. Andromeda is not a fixed object in space. It is a system in motion, shaped by gravity, influenced by hidden forces, and constantly changing as it interacts with everything around it. From its outer halo of ancient stars to its dense and active core, every part of it tells a story of formation, of growth, of interaction, and of transformation. This story does not belong only to Andromeda. It is shared by every galaxy, every structure in the universe, showing us that the cosmos is not static, but dynamic, a place where change is constant and where nothing remains exactly the same forever. The future collision with the Milky Way is one of the clearest examples of this, a process that will reshape both galaxies and create something entirely new, continuing the cycle of evolution that has been unfolding for billions of years. What makes this even more profound is that this process is already happening, even if we cannot see it directly, because the motion of Andromeda toward us is a present reality, a movement that connects our galaxy to it across vast distances and timescales. This connection reminds us that we are not separate from the universe, but part of it, part of the same system that shapes galaxies and drives their evolution. When we look at Andromeda, we are not just looking outward, we are looking into a mirror of our own cosmic future, a future that will unfold long after we are gone, but one that is already written into the motion of the galaxies themselves. And this is what makes the story complete. The understanding that everything we observe is part of a continuous process, a system that connects the past, present, and future into a single, ever-changing reality. In the end, Andromeda is more than just a galaxy. It is a reminder that the universe is alive with motion, filled with structures that grow, interact, and transform over time, and that even the most distant objects are part of the same story, a story that continues to unfold across billions of years, shaping everything we see and everything we are. Even after everything we've explored, there is still one final way to understand Andromeda, not just as a galaxy, but as a perspective, a way of seeing the universe that goes beyond distance, beyond scale, and into the nature of reality itself. Because what Andromeda truly shows us is that everything we observe is part of a continuous flow of time, a process where nothing is ever truly still, even when it appears that way. The stars within it are always moving, the structure is always evolving, and the galaxy itself is always changing, even if those changes take millions or billions of years to become visible. This means that what we see when we look at Andromeda is not a fixed object, but a moment, a single frame in an ongoing sequence that stretches across the entire history of the universe. And this idea changes everything, because it shows us that the universe is not something we can fully capture in a single observation, but something we can only understand by piecing together moments across time. Andromeda becomes one of those moments, a system that allows us to see how galaxies behave, how they form, how they interact, and how they eventually transform into something new. But it also reminds us that there is always more beyond what we can see, more layers, more complexity, more processes that are happening outside of our current understanding. This is what makes the universe so powerful as a concept, not just its size, but its depth, the idea that every object, every structure, contains more than what is immediately visible. Andromeda is a perfect example of that depth, a galaxy that appears simple from a distance, but becomes incredibly complex as we study it more closely. And yet, even with all of this complexity, it still follows the same fundamental laws as everything else, showing us that the universe, despite its vastness, operates with a kind of consistency that allows us to understand it. This balance between complexity and simplicity is what makes cosmic structures so fascinating, because it allows them to be both predictable and mysterious at the same time. Andromeda exists within that balance, revealing patterns that we can study, while also hiding details that we have yet to uncover. In the end, what Andromeda gives us is not just knowledge about a distant galaxy, but a deeper understanding of how the universe works, a system that is constantly evolving, constantly changing, and constantly revealing new aspects of itself as we continue to observe and explore it. As we approach the final layers of this journey, Andromeda begins to reveal something even deeper, something that goes beyond galaxies, beyond stars, and into the nature of existence itself. Because what this galaxy ultimately shows us is that the universe is not defined by what we see, but by what continues beyond our perception. Every observation we make is limited. Every image we capture is only a fragment, and yet within those fragments we are able to uncover patterns, laws, and structures that extend far beyond what is directly visible. Andromeda is one of those fragments, a distant system that carries within it the evidence of processes that occur everywhere in the universe, allowing us to understand how matter behaves on the largest scales. But at the same time, it reminds us that there is always more beyond what we can observe, more layers, more complexity, and more interactions that we have yet to fully understand. This balance between what is known and what remains hidden is what drives our exploration, pushing us to develop better tools, better theories, and better ways of interpreting the signals we receive from space. Andromeda has played a crucial role in this process, serving as a reference point for understanding galaxy formation, dark matter, and cosmic evolution, helping us refine our models and expand our knowledge of the universe. And yet, despite all of this progress, it still holds mysteries, still challenges our assumptions, and still forces us to question what we think we know. This is what makes it so important not just as an object of study, but as a source of insight, a system that continues to reveal new information as our ability to observe improves. When we consider this, we begin to see that the universe is not something we can fully understand all at once, but something we approach gradually, piece by piece, observation by observation, building a picture that becomes clearer over time, but is never truly complete. Andromeda is part of that picture, a key piece that helps us connect different aspects of cosmic evolution, from the formation of stars to the interaction of galaxies and the large-scale structure of the universe. In the end, what Andromeda represents is not just a galaxy, but a step in our understanding, a reminder that knowledge is always expanding, that there is always more to discover, and that the universe is far deeper, more complex, and more fascinating than we can ever fully comprehend. And now, as everything comes to an end, Andromeda is no longer just a distant galaxy in the night sky. It becomes something far more meaningful, a reminder of what the universe truly is, a place defined not by stillness, but by motion, not by permanence, but by change, and not by isolation, but by connection. What we once saw as a faint glow has revealed itself to be a vast and complex system, filled with billions of stars, shaped by gravity, influenced by invisible forces, and evolving across billions of years in ways that are both predictable and mysterious. Every part of Andromeda tells a story, from its ancient outer halo to its active core, from the remnants of galaxies it has absorbed to the future collision that will transform it completely, showing us that nothing in the universe exists in a fixed state, and that everything is part of a continuous process of formation, interaction, and transformation. And perhaps the most powerful realization of all is that this story is not separate from us, because Andromeda is moving toward our own galaxy, and one day, far in the future, both will merge into a single system, creating something entirely new, something that carries the history of both, while becoming something greater than either one alone. This connection changes how we see the universe, because it shows us that distance does not mean separation, that even objects millions of light years away are part of the same cosmic structure, influenced by the same forces, and moving within the same system that we are part of. When we look at Andromeda, we are not just looking outward. We are looking into a future that is already set in motion, a future that reflects the same processes that have shaped galaxies across the universe for billions of years. And in that moment, everything becomes clear, that the universe is not static, not silent, but alive with motion, filled with systems that grow, change, and evolve over time, and that even the largest structures are part of an endless cycle that continues far beyond anything we can fully comprehend. In the end, Andromeda is more than a galaxy. It is a window into the nature of the cosmos itself, a reminder that everything we see is part of a much larger story, a story that stretches across space and time, connecting the past, present, and future into a single, ever-changing reality. This is stellar depth. As we move beyond everything we have seen and understood, Andromeda begins to take on a different meaning, no longer just a galaxy defined by its stars and structure, but a symbol of something far greater, the continuous unfolding of the universe itself. What makes Andromeda so powerful is not only what it is, but what it represents, a system that has existed for billions of years, shaped by forces we are still trying to fully understand, and still evolving toward a future that is already set in motion. Every part of it, from the faint outer halo to the dense and luminous core, exists because of a balance between gravity and motion, a balance that allows structure to form and persist, but that is never permanent, always subject to change. This balance has been tested countless times in Andromeda's history, through interactions with smaller galaxies, through internal processes that reshaped its structure, and through the constant movement that defines its place in the cosmos. And yet, despite all of this change, the galaxy remains, continuing to exist as a coherent system, demonstrating the resilience of cosmic structures and the power of the laws that govern them. But what makes this even more significant is the realization that Andromeda is not isolated. It is part of a larger network of galaxies, all moving, interacting, and evolving together over immense distances and timescales. Its future collision with the Milky Way is just one example of this interconnected system, a process that will transform both galaxies and create something entirely new, continuing the cycle of cosmic evolution. This perspective allows us to see Andromeda not just as a distant object, but as part of a larger story, one that includes our own galaxy and extends far beyond it. It shows us that the universe is not made up of separate pieces, but of connected systems, each one influencing the others, each one contributing to the overall structure of the cosmos. And within this structure, change is constant, driven by the same forces that have shaped Andromeda from the beginning, and that will continue to shape it in the future. When we step back and look at this entire process, it becomes clear that Andromeda is not just a galaxy, but a reflection of the universe itself, a system that reveals how everything forms, evolves, and transforms over time. In the end, what Andromeda gives us is not just knowledge, but perspective, a way of understanding the universe as a dynamic and ever-changing system, where even the largest structures are part of an ongoing process that never truly ends, but continues to unfold across billions of years, shaping everything we see and everything we are part of. And now, at the very end of this journey, everything becomes simple again, not because the universe is simple, but because we finally understand what we are looking at. Andromeda is no longer just a distant galaxy, no longer just a collection of stars in the night sky. It becomes something far more profound, a reminder that the universe is not built around stillness, but around motion, not around permanence, but around change, and not around isolation, but around connection. Every star within it, every movement, every hidden force, all of it exists within a system that has been evolving for billions of years, shaped by gravity, influenced by interactions, and constantly moving toward new forms. What we once saw as a faint glow has revealed itself to be a vast and complex structure, one that carries the history of its past, the reality of its present, and the certainty of its future. And that future is not separate from us, because Andromeda is moving toward the Milky Way, and one day both galaxies will merge, creating something entirely new, something that continues the same process that has shaped the universe from the very beginning. This realization changes everything, because it shows us that distance does not mean separation, that even objects millions of light-years away are part of the same cosmic system, influenced by the same forces, and connected through the same laws of physics. When we look at Andromeda, we are not just looking outward, we are looking into a story that includes us, a story that connects the smallest scales to the largest, and that continues to unfold across time in ways that we can only begin to understand. And in that moment, the universe no longer feels distant or abstract. It feels connected, continuous, and alive with motion. In the end, Andromeda is more than a galaxy. It is a window into the nature of reality itself, a reminder that everything we see is part of something greater, something that never stops evolving, never stops moving, and never truly ends. And even after the story feels complete, there is still something that remains, a quiet understanding that goes beyond everything we've explored, because Andromeda was never just about distance or scale, or even galaxies themselves. It was about perspective. The moment you realize that the light from this galaxy left millions of years ago, that its future is already written in motion, and that its path will one day reshape our own galaxy, everything changes. The universe no longer feels like something far away. It becomes something you are inside of, something you are part of, something that continues whether it is observed or not. Andromeda becomes more than an object. It becomes a reminder that existence itself does not wait, it does not pause, and it does not depend on being seen to continue. Every star within it is moving, every structure is evolving, every force is active, even in silence, even in darkness, even across distances we can barely imagine. And this is where the true meaning lies, not in what we can measure, but in what we begin to understand, that the universe is not something separate from us, but something we are already within, connected through the same laws, shaped by the same forces, and moving through the same reality. When you look at Andromeda now, you are no longer just seeing a distant galaxy. You are seeing time itself, stretched across space, carrying the past into the present and pushing everything toward the future. And in that moment, everything becomes clear, that the universe is not silent. It is simply too vast for us to hear all at once, that it is not still, it is simply moving on scales beyond our perception, and that it is not empty. It is filled with stories, each one unfolding across billions of years. In the end, Andromeda leaves you with one final thought, not about what it is, but about what it reveals. That everything you see, everything you are, and everything that exists is part of a single, continuous story, one that has no true beginning, no true end, and no boundaries, only motion, only change, and only the endless depth of the cosmos. And even now, after everything has been explored, there is still one final layer to this story, a quiet realization that lingers long after the last image fades, because Andromeda was never just something to observe. It was something to understand, something that changes the way you see everything else. When you look at it now, you no longer see a distant spiral of light. You see motion. You see time. You see a system that has been evolving long before us and will continue long after we are gone. You begin to understand that what we call the present is only a thin layer, a brief moment between an immense past and an even larger future, and that every galaxy, every star, every structure exists within that flow. Andromeda becomes a reminder that nothing stands still, that everything is part of a process that never pauses, never stops, and never repeats itself in exactly the same way. Its stars continue to move, its structure continues to evolve, and its path toward the Milky Way continues, slowly but inevitably, guided by the same forces that shape the entire universe. And in that realization, something shifts, because you are no longer just looking at space, you are looking at a system that includes you, a system that operates on principles that apply everywhere, from the smallest scales to the largest. The distance between us and Andromeda no longer feels like separation, but like perspective, a difference in scale, not in connection. Everything is still part of the same structure, the same laws, the same reality, and this is where the story truly ends, not with a conclusion, but with an understanding that the universe is not something we watch from the outside, but something we are already inside of, something that continues whether we observe it or not, something that carries us forward just as it carries galaxies through space. In the end, Andromeda is not just a galaxy, it is a reminder that everything you see is part of something far greater, something that has no edges, no boundaries, and no final point, only motion, only time, and only the endless expansion of the cosmos. And in the very end, when everything becomes still again, when the motion feels too vast to follow, and the scale too great to fully grasp, Andromeda remains, not as a distant galaxy, but as an idea that stays with you, a reminder that the universe is far deeper than what we first imagine, because what we have really discovered is not just the structure of a galaxy, but the nature of reality itself, a reality where everything is in motion, where time stretches across unimaginable distances, and where even the largest structures are part of a continuous, unfolding process. Andromeda shows us that nothing exists in isolation, that every object, no matter how far away, is part of a larger system, connected through gravity, through motion, and through the fundamental laws that shape everything. It reminds us that what we see is only a fraction of what is real, that beyond every point of light there are systems we cannot fully observe, and that the universe extends far beyond the limits of our perception. But more than anything, it changes how we see ourselves, because when you understand that you are part of the same universe that creates galaxies, that follows the same rules, and that exists within the same flow of time, the distance between you and Andromeda no longer feels infinite. It becomes a matter of scale, not separation. And in that moment, the universe becomes something else entirely. Not just a place you look at, but something you belong to, something you are already inside, something that continues to move, to evolve, and to exist, with or without observation. And this is where the story truly closes, not with an ending, but with a realization that there is no final point, no boundary where everything stops, only a continuous expansion of knowledge, of understanding, and of the universe itself. In the end, Andromeda is not just a galaxy in the sky, it is a reflection of everything, a reminder that existence does not end, that it continues in ways we can barely comprehend, and that what we call the universe is not something distant, but something endless, something infinite, and something we are already a part of. And even beyond this final moment, there is still something that lingers, something that cannot be fully explained, only felt. Because when you step back from everything you've seen, from the scale, the motion, the endless depth of Andromeda, you begin to realize that the universe is not something you can finish understanding. It is something you can only continue to explore. Every answer leads to something deeper. Every discovery reveals something more complex, and every observation reminds us that what we know is only a fraction of what exists. Andromeda becomes the perfect symbol of that idea. Not just a galaxy, but a doorway into something far greater, a structure so vast that it stretches our imagination, yet so precise that it follows the same laws that govern everything around us. Its stars continue to move, its structure continues to evolve, and its journey toward the Milky Way continues, slowly, silently, but inevitably, as part of a process that cannot be stopped or reversed. And in that movement, there is something constant, something that connects everything, from the smallest particle to the largest galaxy, a shared existence within the same system, the same reality, the same universe. This is what remains at the end, not just knowledge, but perspective, the understanding that there is no final boundary, no ultimate edge where everything ends, only an endless continuation of motion, of change, and of discovery. When you look at the night sky now, it is no longer just a collection of stars. It becomes a reminder of something infinite, something that goes on far beyond what you can see, far beyond what you can measure, and far beyond what you can fully comprehend. Andromeda is still there, moving, evolving, existing, whether it is observed or not, a silent presence in the vastness of space, carrying with it the story of the universe, a story that has no beginning we can reach, no end we can define, only an endless depth that continues forever. And in that depth, the journey never truly ends.